India's first animated live tuition. Can you hear me? Yes. Okay, so please turn on your camera. Everybody, please switch on your camera. Can you please open all the chat boxes, please? Okay, so good evening and please turn on your camera, everyone. Okay, so we were discussing chapter number 1, number systems, right? Yeah, chapter number 1. Who is that?
You got it.
Yeah, okay. Yeah, fine, thank you. And what about you? Okay. Yeah, who's that? No.
Ashika.
Okay. Yeah, thank you. And welcome to the class, everybody. Is there anyone who is attending this class for the first time?
Is there any difference?
No, please. Okay, so any new students, if you are new to this class, can you please raise your hand? Please, yes. Okay, we have some hand raises. There is an option. Okay, you can see one icon, raise hand. Okay, please just click on it. Otherwise, we may miss your hand raises. Please don't raise your hands like this. Okay, you can just click on it. Yeah. I just saw some. Yes. Can you please unmute her?
Saifana.
Yes. Okay, please unmute yourself and please introduce yourself in 2 sentences, like what is your name, from where are you coming, like that. Okay, first one.
Saifana. I think so.
Okay, please unmute her. Hello.
Hi, ma'am.
Hi. What is your name?
Hi. My name is Saifana Fatima.
Okay.
I am from Qatar.
Okay. Welcome to the class, Saifana, right?
Same.
Yes, ma'am.
Safe. Okay. Yeah, anyways, welcome to the class and I'm so happy to see you. Okay, next one, sir.
Afia.
Okay. Please, hi.
I'm from Tamil Nadu.
Okay.
I'm
Yeah, okay. Yeah, welcome to the class. Next one,
Manish.
Manish. Oh, we have another Manish here. Yeah. Yes, Manish. Please unmute. Hi.
from Tamil Nadu.
Okay, Manish. Welcome to the class. Next one,
Satya.
Satya. Okay.
Good evening, ma'am. I'm Saigita.
Saita.
Saigita, ma'am. Saigita.
Saigita. Okay.
I
Sai
study
Geeta.
in Unified School. I'm from Tamil Nadu.
Okay. Yeah. Welcome to the class. Next one, sir.
Anu.
Anu. Okay.
Good evening, ma'am.
Good
My
evening.
name is Anu. I'm from Kerala and I'm studying in Abu Dhabi Indian School.
Okay. Welcome to the class. Next one. Any other hand raises?
Shida.
Okay.
Good evening, ma'am. How are you?
Yeah, I'm fine. What about you?
I'm fine, ma'am.
Yeah, okay. And your name is?
Ma'am, I'm Rakshita
Rakshita.
and I'm from Andhra Pradesh and I'm attending this class from Abu Dhabi.
Okay, Akshida. Welcome to the class and I'm so happy to see you.
Rikshida.
Rakshida. Okay.
Thank you.
Yeah. Okay. And that's it, right? Any other hand raises? Okay. So welcome to the class, everybody. To the new students, all students, everybody. Okay, welcome to the class. Can you continue with polynomials? After completing this, okay. Let's finish this very quickly and we can go back to this polynomials. Yeah, anyways, and my name is Anila and I'm your maths teacher from 90 Plus Hybrid Tuition. I welcome you all to this tuition. Okay, so we were discussing about some number systems and all this. Natural numbers, all numbers, integers, rational numbers, irrational numbers, then together they form this real numbers. And many of you were asking about, yeah, thank you.
Right.
Okay, so many of you were asking about the representation Wait a second. Representation of square root of decimal numbers on number line, right? Especially this root 9.3. So let's see how we can represent this decimal numbers or the square root of decimal numbers on number line. Sir, please play the video. First, let's see root 9.3. Many of you were asking about this root 9.3. So let's see that first. Root 9.3. Yeah, as you know, first of all, we have to draw a line and it is 9.3 centimeter. Then that is named as AB. Along with that, we have to add 1 more centimeter. So, and we will name that point as C. So together we have this 10.3 centimeters and we have to find the midpoint of AC. Okay, to find the midpoint of AC, we will take a distance on this compass which is greater than, like, more than half of this distance of AC. Okay, approximately we know the half distance and we have to find the exact point. For that, we have to draw a perpendicular bisector. So we are taking a distance on this compass which is greater than half of AC. Okay, and we will draw an arc above that line, yes, and below that line. Now taking this compass and placing it on A, we will again draw 2 arcs. Now we will draw a line and this line is actually the perpendicular bisector of AC. What is this perpendicular bisector? A line which is at 90 degrees and it divides this AC into 2 equal halves, right? Okay, so that point where this perpendicular line touches AC is the center of AC, not center, middle point of AC, midpoint of AC, and we just name it as O. Okay, and now we have to draw, yes sir, and we have to draw a semicircle and the radius of that circle is this distance OA. Okay, or taking AC as the diameter, we are drawing a semicircle. Now the next step is we have to draw a perpendicular line from B, okay, so that it touches the semicircle at some point, say D. Okay, so now the next step is we have to take a protractor, mark this 90 degree and draw a line so that that line touches this semicircle at the point D. That distance will be equal to root 9.3. Taking that on this compass, we have to draw an arc and this arc will touch this line at the point, at some point, and that point is root 9.3. Okay? Yeah.
Niranjan,
Yes, Niranjan. Niranjan, you are not audible. Hello? I can't hear you. Is there any network issue, ma'am? Maybe. Please
No,
pin
ma'am.
him. Niranjan, say something. No, you are not audible. Can you please drop a message in the chat box? Okay, yeah. Next one, ma'am. Hand raise.
Ashley,
Yes, Ashlyn.
Why do we take 9.3 from point B and not from point A?
9.3 from?
See, BD is equal to root 9.3, right?
Yes.
So, ma'am, after we take root 9.3 on the compass, can't we just plot it from A?
No, we have to draw it from that point. Yeah, okay. What happens? No. From that point. Okay.
But why can't we plot from A? Like, we take the distance and then put it on A and then plot the root 9.3.
Yeah, but okay, ma'am. Any answers? Huh?
it's in the text, right?
No. Like, we are taking a distance and why can't we draw it from A? Like,
Can you hear me now?
yes, I can hear you. Yeah.
You can ask me this.
Yeah, I know what is your question, but wait for 2 minutes. Okay, ma'am will.
Oh,
Yeah, please check, ma'am, and please. Okay. What?
Then
Niranjan, is that Niranjan? Yeah, yes, Niranjan. Yeah, I thought it is the other person. Yes, Niranjan.
Niranjan?
Ma'am,
Ah,
ma'am, the question was, ma'am, like,
Ah.
so should we draw that circle from A to C or from C to A?
from A to C or C to A, both are same. We are drawing a semicircle with this distance. AO is equal to CO. So you can take this radius on this compass and you can just draw a circle from C to A or A to C. Both are same. You will get the same semicircle. Okay. Yeah.
Oh, okay, ma'am.
Okay.
And then-
Then next.
Head on sheet.
Okay.
Ma'am, I had a doubt. Like over here, you have drawn the D1, okay, root 9.3. Then how did you make that one? Like how, from where you took it, the marking?
Marking. Okay. So when we drew.
9.3 D1, D.
Yes. Okay. Actually, to draw the roots of this decimal numbers, we will usually follow this method. Okay, we will just take that distance in a scale. Like if it is 9.3, we will take that distance in a scale and then we add 1 more centimeter to it and we will follow the same steps. And when we draw a perpendicular line from B to D, that will be the desired or the required distance. If it is root 4.5, we just draw this 4.5 first, then we just add 1 centimeter to it. Okay, let me show you some other videos. It's like that. When we draw this and we will get a distance from B to D, that will be root of 9.3. So that is root of 9.3. Taking that on this compass, we can draw an arc and it will be root 9.3 on this number line. Okay.
No, ma'am, actually I understood that point, but like what distance you took to draw that curved one?
Okay, you don't have to take any distances. You can just draw a semicircle first. From A to C or C to A, just draw a semicircle. And we have this point B, no? Just draw a perpendicular line from B to this semicircle. The point where that line touches this semicircle will be D. You don't have to take any distances. Just draw a perpendicular line from B. Okay. Don't take any distances. Just draw a perpendicular line and it will touch the circle at some point. No. Just name that point as D and that distance will be root 9.3.
Yeah, that much I understood.
Ah.
But my actual question is, can you see when you mark the root 9.3? Yeah, that one how you made it.
What?
My question is that,
Mm.
like, can you see the root 9.3? How you made the D to that? I understood it is 90 degrees.
Okay, after drawing that perpendicular line, just take that distance. It will be 9.3, root 9.3. Okay, following this method, you will get this root 9.3. This distance will be root 9.3. For all the decimal numbers, for the square root of all the decimal numbers, we follow this method. And after drawing this BD, you will get the required distance. Okay. And you can just take that on this compass and just draw. It will be root 9.3.
Okay, ma'am.
Yeah.
Now I got it.
Yeah, okay. Then next.
Abid.
Yes, Abid.
No? Abid. Okay.
No, okay.
Ruben Bijoy.
Yes, Ruben. Ah,
Can you explain some quantum manufacturing and understand this?
okay. Yes, sir. Can you please play this from the beginning? Sir, please play this once again. Okay, so first of all, we need to draw root 9.3. So just place a scale and draw. Okay, so stop. Yeah, just draw a line of length 9.3 centimeters. Okay, just we need root 9.3. Right, wait. Okay, we need root 9.3 on number line. So for that, just draw a line segment of length 9.3. If it is root 4.5, just draw a line of length 4.5. If it is root say 13.6, just draw a line of length 13.6. So we can see some more examples. Here we need root of 9.3. So we are just taking this 9.3 on the scale. And then after that we have to add 1 more centimeter to it. Okay, and we are just naming this starting point as A and this end point as B. And again we have to add 1 more centimeter to this line. So this is 1 more centimeter. So that point is C. Now we have to find the midpoint of this AC. Okay, we have to find the midpoint of AC. For that, what we do is we just take a distance. Now just see this. Here, that point, if we name this point where this compass touches this line, okay, compass touches this line as say P, you can see that this AP is less than this CP. So just take a distance which is just more than half of this AC. We don't know where is the exact midpoint, but we can just imagine, yeah, here will be the midpoint. So just take a distance which is more than half the distance of AC. Just take that on compass, yeah, and we have to find the perpendicular bisector of AC. What is the perpendicular bisector of AC? It will be a line which cuts this AC into 2 equal halves. So that point where this line perpendicular bisector touches AC will be the midpoint of AC, right? Yeah, so yes sir, please play the video. So to draw the perpendicular bisector, we just took it on this compass and we will draw an arc above and below. Now from this point A, we have to do the same thing. Now just connect them. We will get a point, or this line perpendicular bisector will intersect the line AC at a point, and that point is O. Okay, and now we have to draw a semicircle of radius AO or CO. Here you can see that, yeah, okay, OA is equal to OC. Please go back. Okay, we have to see, we can see that OA is equal to OC because O is the midpoint of AC. So from the midpoint, the distance from A to O and the distance from C to O both are same. Okay, now taking that as the radius, we have to draw a semicircle. So we just draw a semicircle there, and then from this point B, we have to draw a perpendicular line to this semicircle. We have to draw a perpendicular line to this semicircle. So how to draw a perpendicular line? We just take a protractor and we just measure this 90 degree, and then we will draw a line. That line will touch the semicircle at some point. Yes sir, please play the video. That okay, that line will touch the semicircle at some point, and that point is D, and the distance BD will be equal to the required distance root 9.3. Now we extend the line and we take that distance on the compass and we will draw an arc like that. That will be root 9.3. Okay, now let's see one more example, then it will be more clear. Sir, can you please play the next one, root other one? Yeah. Yes. Now let's see another one, root 4.5. Okay, so we have to draw, wait a second, we have to draw, or we have to show this root 4.5 on number line. So just before this, it was root 9.3. So we just took a distance 9.3 on scale. Now we need to show root 4.5. So we just take this 4.5 on scale. Yes, and we will draw a line. Yes, sir. And we will draw a line like this. Okay, 4.5. And what is the next step? We have to add 1 more centimeter to it. Yeah, and that will be C. Now what is the next step? We have to find the midpoint of AC. Everywhere the steps are same, only the values are changing. Okay, steps are same, so we have to find the midpoint of AC. For that, what we take is, we just take the distance more than half of this AC and we will draw an arc just above and below the line. Then from point A also we will do the same thing. Then we will draw a perpendicular bisector, yeah, and that line will touch this AC at the midpoint of AC, and we just name that point as O. Okay, now we have to draw a semicircle taking radius AO or CO. Okay, we just draw a semicircle. After that, we have to draw a perpendicular line from B to the semicircle. Okay, We just take a protractor, place it and mark 90 degree, then draw a line from B to the semicircle. So this line will touch the semicircle at the point D. That distance BD will be equal to root 4.5. Taking that on compass, just draw an arc and that will be root 4.5. This got cancelled for us. Okay, many of them were asking about this root of 9.3, square root of numbers. So I just want to show you this. Okay, many doubts were coming, that's why. Yeah. Okay, so this is how we represent the square root of decimal numbers. Okay. Yeah, ma'am, hand raises.
Sanjit.
Yes, Sanjit.
Yes, ma'am.
Any doubts?
No, ma'am, I just wanted to answer now.
Okay, yeah. And next one, Abid, any doubts? Please. Any doubts?
I can't find the center of the semicircle.
Okay, you don't have to actually find the center. Okay, see, if we have a line, we don't know where is the exact center or the midpoint of this line, but we just know that this is this distance. Okay, if we name this as A, this as B, this distance C, this AC is more than half, right? Just see this. Okay, we can just imagine the midpoint will be, we don't know the exact midpoint, but still we don't know this where is the exact point, but still we can know that this AC is little bit more than half, right? Okay, so just take a point which is a little bit more than half of this distance AC. Here we are drawing AC and we have to find the midpoint of AC. For that we have to draw a perpendicular bisected so that it will touch the this line at exact midpoint and it will cut that line into two equal parts. But to find that we have to take a point somewhere here. Okay, some E or something, and just take that distance AE on compass and draw an arc. Okay, a little bit more than half the distance. Okay, that's it. You don't have to find the exact center. First draw this perpendicular bisected, then that will touch the line at exact midpoint. This will be the exact midpoint. Otherwise we can't find the exact midpoint. Just take, okay, just imagine this distance and just take a distance more than half of the distance. Okay, yeah, that's it. Any other hand raises, ma'am?
Yes. Mitesh.
Yes, Mitesh.
Ma'am, so we need to take half of E or B? C, right? No, B, right?
Half of AC.
AC. So from C we need to take half, more than.
Okay, to draw the perpendicular bisected, okay, see, we have to draw the perpendicular bisected of AC. If we are taking only this much distance on compass, what happens? From this point we will draw an arc here, and from this point we will draw an arc here, and from C when we draw an arc, it will be somewhere here. They won't cut each other. Yeah, so that's why we are taking a distance more than half so that they will cross each other. From both the points, they will cross each other. Okay, so we have to find the midpoint of AC.
Okay.
Yeah. Okay, next one.
Muhammad Suhail.
Yes, Suhail, do you have any? Yeah, no. Okay, so this is how we draw. Any other hand raises? No.
Suhail.
Yes, Suhail, do you have any doubts?
Yes, ma'am, but this is not a number line at all. This is just a line.
Yeah, just a line. Okay. Actually, this is not there in your textbook, right? Root
Yeah, it's not.
4.5. Yeah, many of them were asking about how to draw this on a line. Yeah, that's it. I don't think such questions will be there for your exam, but still many of you were asking. Just, okay. We can do this on a number line. Just take B as 0. Okay, the origin. If you want to do this on a number line, just take this B as the 0, the origin. Then you can follow the same steps. Okay. Ma'am? Yeah, okay. If you want, you can see one more square root of decimal number, and after that we can stop this. Okay, sir. The next one, root for 3 point.
Ma'am, one more hand raise.
Yes.
Mas.
Mas, yes, Mas.
Actually, right now, not
Or you want to see the diagram?
you draw it
And
Must. Can you repeat?
No, I'm asking. Actually, draw the diagram.
right.
Must.
Now, should you draw the diagram?
Draw the diagram. Okay. Sir, can you please show that diagram once again? Yeah, the previous one. Please mute. Okay. Yeah. This is the diagram. It's already discussed. Just okay. Yeah. And now one more square root of decimal number. Yes, the next one. Okay. Root. Yes. We have to draw the square root of 3.2. Okay, so just draw this 3.2 first, that is AB. Then what we have to do, we have to add 1 more centimeter to this. For any square root of decimal numbers, you can follow the same steps. Okay, just take that measure. This is root 3.2. So just take 3.2 on scale, it is AB, 3.2. Then yes sir, next, then add 1 more centimeter to it, that will be C, that point will be C. Okay, now please play. Okay, that point will be C. Now we have to find the midpoint of AC. Okay, so we will take a distance more than half and we will draw arcs just above and below the line. Then from point A also we have to do the same thing. Then draw the perpendicular bisector of AC. That point will touch the line at O. Okay, and then taking this AO as the radius, just draw a semicircle. Now from this B to that semicircle, we have to draw a perpendicular line. So we just place a protractor there and we will just measure 90 and we will draw a line. That line will touch this semicircle at the point D. That distance will be root 3.2. Just take that root 3.2 on compass and draw an arc. That will be root 3.2. Okay? Yeah, that's it. That is the square root of decimal numbers. Yeah, that's it. And one more thing. Yeah. Yes, ma'am.
Iman.
Yes, Ayman.
Yes, ma'am. I just found out that it's not necessary to draw the line between the semicircle. I can do it without that. And I just.
How do you do that?
Ma'am, I just first of all I extend 1 centimeter and then I take half of it on the scale and I just draw the semicircle and I get it perfectly. Then from point B, I just draw a straight line. I get the perfect 90 degrees and then I make a arc. That's it.
Oh, okay. Yeah. To make this more precise, like on the scale, we can take half, but to make this distance more precise, we are using this method. You can just use a scale to measure, but still this is 3.2, 4.2, so there are chances we may make mistakes. So in order to make this more accurate, we are using this method. You can also do that. Okay. Yeah. Yes, that's it.
No, Rayman, Raima.
Okay.
Ma'am, how did you find the half?
Half. That is why we are drawing this perpendicular bisector that will touch this line exactly at the midpoint. That is how we find the half of it.
Exactly. How did you find the half?
Why?
How did you find the half?
Yeah, that is why we are drawing this perpendicular bisector. Perpendicular bisector of a line means it will touch the line at exact midpoint. So that will be the half of it.
Yeah, but how to find it? Like,
This is how we find this.
okay.
Yeah, just draw a perpendicular bisector. That line, okay. Do you mean how to take more than half distance? Do you mean that? Not this one. Yeah, this one you can just draw a perpendicular bisector, which means just take more than half distance. Okay, if this is AC, just take a distance up to like this much distance, take on compass and just draw an arc just above the line and below the line. From this point A also just draw an arc here and another arc here and just draw a line. This line will touch exactly at the midpoint. Okay, will be the half of it. Yeah, that is the meaning of perpendicular bisector.
Yeah, that's all.
Yeah.
Yeah.
Okay. So if you want to draw root of something, root of 13.6, first of all draw 13.6 centimeter, then along with that 1 centimeter more, then do the same steps. Okay, you have to follow the same steps. Yeah, that's it. Yes ma'am, any other hand raises?
No, ma'am.
Okay. This chat box, we should draw, do we draw 4.2 or 4 centimeter? Yeah, the last chat box.
To draw 3.2. After drawing 3.2 for the
Next centimeter, we should draw. Do we take, yes, we take 4.2 along with 3.2. If we take one more centimeter, that will be 4.2, right? So this distance together, it is 4.2, not 4, it is 4.2. Okay, yeah, and the other one, will this definitely come in exam? Okay, square root of decimal numbers, I don't think so, but I just want to show you this. Many of you were asking. All other like root 2, root 3, you can draw the square root spiral, and that were already discussed. Yeah, that's it. And one more thing. Yeah, so the first one, 2 plus root 2. We already know how to draw root 2, root 3, etc. on this number line. What about this 2 plus root 2 or 3 plus root 3 or 2 plus root 3, something like that? How do we represent that on number line? If it is just root 2, what we do is from this, okay, we have 0, 1, 2. From this point we will start from 1. Okay, but if it is 2 plus root 2, we have to take it after 2. Okay, after 2. 2 plus root 2. Along with 2, we need root 2. Yeah, sir, please show the video. So first of all, draw the number line. Okay, 0, 1, 2, 3, 4. Just mark the numbers. We need 2 plus root 2. So you have to start from the point after 2. Okay, for this root 2, we will start from 1. Just root 2, we will start from 1. So this is 2 plus root 2. So you have to start from 3. Yeah, just draw a semicircle. Or just, okay, you can just use a protractor. You know how to draw root 2, right? Using a protractor, just mark 90 degree. We just show that in class using compass and using protractor. You know how to do this. So just draw this root 2 after 2. Okay, if it is 2 plus root 2, yeah. So here I am showing it using the compass. Just draw a semicircle and then, yeah, now play it. What you have to do is just draw, yeah, just draw a perpendicular line from this 3. Okay, I am just drawing it using a compass, that's it. Okay, we are drawing a perpendicular distance and we need it to be equal to 1 centimeter. Okay, yeah, that is how it works, right? For this root 2, we just draw 1 centimeter, 1 centimeter. So this will be root 2. Okay, yeah, just draw root 2 there, that's it. Just take that distance from 2 to 3 on compass. Yes, sir. Then mark that distance, join them from 2 to that point, join a line, and then take that distance on compass and draw root 2. It will be 2 plus root 2. So basically what you have to do is, if it is 2 plus root 2, you have to draw it after 2. If it is 3 plus root 2, just draw it after 3. Okay, that's it. You know how to represent root 2, root 3, etc. So first of all, what you have to do is just do this. Okay, after 3 you have to start. Yeah, these were some of the extra questions you were asking. That's it. Okay. Everybody, do you have a notebook? Who is it? Okay. Name?
Adya.
Adya, do you have a notebook? Okay. So everybody, please keep a notebook. Okay, and not about this one, other question, you have to write it down in your notebooks. Okay, please make sure that you will take the notes during the class time. Sometimes after the class, I may ask you to submit the notes. So it must be there in your notebooks. Okay, please don't be lazy in the class. And to the new students, okay, we have some instructions. We have a whole team here to monitor you. So please don't turn off your camera during the class time. Your camera must be on throughout the class. And yeah, please maintain a notebook for each subject. Okay, and please do write down the notes during the class time. Okay, yeah, follow the same steps, others. Okay, so this is how we represent 2 plus root 2. Yes, sir, please remove. These were some extra questions. Yeah, that's it. Now let's see the next topic, that is, okay, so we have already seen the division of 10 by 3, 7 by 8 and 1 by 7 in our previous class, right? Yeah, so when we divide 10 by 3, we will get 3.3333 like that. Show again, which one? 2 plus root 2? Sir, that video. Two plus root 2, right? Ma'am, here also. What doubt? Can you please raise your hand if you have doubts?
Aradhana.
Yes. We have a hand raised there.
Aradhana.
Aradhana, do you have any doubts here? Play the video, sir. Yeah, please unmute.
Yes, ma'am. 2 plus square.
2 plus?
2 square is the noun, right?
2 plus root 2. It was 2 plus root 2. Okay, do you know how to represent root 2 on number line?
Yeah.
Yeah, so we just start from 1, right? Like we will draw a line 1 centimeter like this, and other one, then we will get root 2 and we will take that, okay, and we will draw an arc, then we will get root 2. So that was just root 2, but here we need 2 plus root 2. So what you have to do is, after 2 you have to do the same thing. Here we just started from 1, so here you have to start from 3. That is the only difference. If it is 2 plus root 2, start from the point just after 2. Then if it is 3 plus root 2, just start it after 3. That is from 4 you have to start. Then if it is 5 plus root 2, you have to start it after 5, or that is you have to start from 6. Okay, that's it. We know how to represent root 2. So if it is 3 plus root 2, just start it after 3. That's it. Okay, yeah. Sir, show the video. Yeah. No, video. Yes, Said.
No, Ramzi Alta.
Renzi, okay. Just play the video, full video. Yes.
So in this 2 plus root 2, 2 will be the origin.
3. Yes. No, it's not like that. 0 is the origin, but we have to draw 2 plus root 3, right? So from 3 we will draw the line. If it is just root 2, we will draw that 1 centimeter from this 1, right? Okay, for this root 2, what we do is, we have this 0, 1, 2, 3, etc. To draw root 2, we will start from 1 and we will draw a perpendicular line of length 1 centimeter here. Yeah, stop the video. Okay, and this distance will be root 2, and taking that on compass, we will draw an arc and we will get root 2 on the number line. But if it is 2 plus root 2, if it is root 2, yeah, we are drawing it on 1. Okay, if it is root 2, we are drawing it on 1. If it is 1 plus root 2, draw it on 2. If it is 2 plus root 2, start it from 3, just like that. Okay, 0 is the origin. Okay, yeah.
And
Rishikesh, yes, Rishikesh?
Yes, ma'am.
Yes, do you have any doubt? Is it easy? Any doubts?
No, ma'am.
No, okay. Yeah, so then any other hand raises, ma'am? No. Okay, sir, remove that. No, please play the full video and just stop. Okay, you have to draw that, and then you can also use a protractor. Okay, you know how to draw this root 2, right? You can also use a protractor. I have shown you the video using protractor and using compass. Here we just use this one. Okay, that's it. You can also use a protractor to do the same. What we need is a 1 centimeter perpendicular line from 3. That's it. Yeah. Okay. Please remove. Yeah, that's it. Now we need, okay, we have already seen this division, right? Yeah, this is 10 by 3 and 10 by 3 was equal to 3.3333. It goes on and on. It is never ending process, and the reminders we got were 1 1 1 1. Okay, and then we have seen the other one, that is 7 by 8. Okay, we have discussed all this in the previous classes. That's why I'm just going a little bit okay quick. Yes, okay, so we just put a decimal point there because we can't divide this 7 by 8 directly, so we just put a decimal point there, so we can just put a 1 0 just beside the 7. It will be 8 8s are 64, then we will get the remainder as 6. Again we have to put 1 0 just beside this one, and 7 8s are 56, and we will get the remainder 4. Okay, we are continuing the process like that, and at a particular point the remainder finally becomes 0. Okay, the remainder is finally becoming 0, but in the previous one the remainder was never becoming 0. It was going on like 1 1 1 1. We were continuously getting the remainder as 1 only, but here at a particular point it is ending. Okay, we will get the remainder as 0, and we have seen one more thing. See, the reminders we have obtained while dividing 10 by 7 was different reminders we have obtained, and it was repeating after, okay, it was repeating after 6 points. Okay, 6 decimal points. It was 0.142857, 142857. Like that it was repeating, and we have seen some properties also, just like this one. Okay, the reminders either become 0 after a certain stage or start repeating themselves. Okay, we have discussed this in previous classes, that's why. Okay, you all know this, right? Yeah, the reminders either become 0 after a certain stage or they start repeating themselves. You can see that here it is becoming 0 after a stage. Okay, it is becoming 0 after a stage, and here the reminders are repeating. Okay, repeating like 1 1 1 1. It is repeating, and here it is repeating like the reminders are 3 2 6 4 5 1. Again we will get 3 2 6 4 5 1. It is also repeating, but after 6 points. Okay, it is repeating. What was it? Sir, please stop that. Okay, so the reminder is either becoming 0 or it start repeating themselves after a certain stage. So we have got two different cases. The first case is the remainder becomes 0. Okay, we are dividing a number by another number. We have this p by q form of rational numbers, which means like 1 by 2, 2 by 3, just like that. We are dividing one number by another number. Okay, and at a certain stage it is becoming 0. The remainder is becoming 0. For example, we can take this 7 by 8. We have seen the division of 7 by 8, and here the remainder is becoming 0. Okay, at a particular point it is becoming 0. What about 1 by 2? We know how to divide 1 by 2, right? Yeah, we can't just directly divide. We have to take a decimal point. Yeah, and we can put 1 0 here. 5 2s are 10, and the remainder is 0. So 1 by 2 is also equal to 0.5, and here the remainder, we have obtained a remainder of 0. Okay, and similarly you can get another examples also. 639 divided by 250 is equal to 2.556. So at a certain stage you will get the remainder as 0. Okay, so if we obtain a remainder as 0, it means that it is stopping there. We can't move further. We can't do it further. If it is not becoming 0, we can do it infinitely. Here, see, we can do as much as we want. Okay, it is going on and on, like the remainder will repeat itself. 1 1 1 1. Okay, the remainder will repeat, but here it is becoming 0. So we can't do it further. It is ending there. That is an end to this decimals. So it is 0.875 only. It is not going further. So we say that, you know this, I know. Okay, we name it as terminating decimals. Okay, terminating. That is terminating. It is ending at a particular point. Okay, so they are known as terminating. Okay, terminating. It is ending at a point. Right? Yeah, it is ending at a point. That is why we name it as terminating. So whenever the remainder becomes 0, this will end. Okay, it will terminate. The decimal expansion of the 7 by 8 will terminate because at a certain stage we are obtaining the remainder as 0. If we got the 0 as a remainder at some point, it is terminating. Okay, it is ending there. You must have watched the movie Terminator, maybe. I don't know. But still. Yeah, anyways, it is terminating, right? It is ending at a particular point. Yeah, 0.5. It is not going like 0.555. No, it's not like that. It is ending at 0.5. So it is terminating. Yeah, so what will be non-terminating? Just the opposite, right? It goes on and on. It is not ending, never ending process, right? Yeah, that is the case number 2. The remainder never becomes 0. So since the first case is the remainder becomes 0, it is terminating. And here the remainder is never becoming 0. Okay, we have to do it again and again. Okay, till our last breath we can do this. Okay, it is a never ending process. The remainder never becomes 0, never. Okay, in such cases you can take the example of 10 by 3. We have seen this in previous class. 10 by 3 is equal to 3.33333. The remainder never becomes 0. Okay, it is 1, 1, 1, 1. After each and every division we will get 1 as the remainder. So this remainder is never becoming 0. So we will get it as 3.3333. It goes on and on. Okay, it is a never ending process, which means we can say that, okay, 1 by 7 also, it is 0.142857. See, after 0.142857, again it is repeating 142857, 142857. So this 142857 is repeating. Okay, 142857 is repeating. And okay, let me ask you a question. We have seen this in previous class, right? What about how we can identify after how many decimals it will repeat after itself? Here this is 3.33, only one digit is repeating, right? And here 1, 2, 3, 4, 5, 6 digits are repeating. Okay, 1, 4, 2, 8, 5, 7, 6 digits are repeating. So how do we identify this? Any idea?
Hand raising.
Yes.
Neha Das.
Yes, Neha.
Ma'am, after 12 decimals.
After 12
12
decimals,
or 11, yeah.
they will repeat. But here only...
No, we can decide if they are repeating or not.
Okay, so is it something related to the divisor? Like here we are dividing it by 1 by 7. So is there any relationship between this number of repeating digits and this divisor?
Ma'am, Chris Robin.
Okay, yes, Chris?
Yes, ma'am, it has a relationship with the divisor, ma'am.
Okay, so what is
If
that
it is
relation?
repeating, it will be less than the divisor, and if it is repeating, it will be more than the divisor.
Yes. Okay, very good, Chris. So here that was our second point. Okay. See the number of entries in the repeating string of reminders. If the reminders are repeating after 6 points. See, here we have the reminders 3, 2, 6, 4, 5, 1. After the stage, it will repeat again. The reminders, the next reminders that we will get us 3, then 2, 6, 4, 5, 1. That is why this quotient, okay, the quotient is also repeating. The decimals in the quotient is also repeating because we will get the same reminder. Yeah, so the repeating block of number of entries in the repeating block or string of reminders is less than the divisor. In 10 by 3, 3 was the divisor, right? So one number repeats after itself. So 1 is less than 3. Since the divisor is 3, only one number is repeating. Here the divisor is 7, 6 numbers are repeating. Okay, so if a divisor is 13, you can always check up to 12 digits. Okay, it may repeat after this 12 digits. Since the divisor is 13, it may repeat itself after this 12 digits, maybe. Okay, there is a chance. So the number of entries in the repeating string of reminders is less than the divisor. So you always have to check for at least a number less than the divisor. If the divisor is 13, just check up to 12. Okay, yeah, that is the relationship between the divisor and this repeating string. Okay, yes. Okay, so we have seen this in the previous class. So here also 6 digits are repeating. Okay, 6 digits. So if they are repeating like that, we can just put a bar on the repeating digit. Here 3 is repeating. Okay, so you first of all you have to write this number 3. Then after that the repeating digit is 3. 3 is repeating. So just put a bar on this above this 3. So we know that this is 3.3333. Instead of writing it as 3.333 etc. we can just write it as 3.3 and above this 3 just put a bar. And here this 142857 is repeating. So you can always write it as 0.142857 and just draw a bar above that. Putting a line on the top of the number before it starts to repeat. Yes. Okay, just do that. And if it is 10.282828, you can just write it as 10.28 and above the 28. 28 is repeating. Just draw a line above that. Okay, just put a line above that. Put a bar. Yes. Okay, so this is how. Yes, and see, this is not terminating. It is not ending at a point. The remainder is never becoming 0 means the quotient never ends. We will always get something in the quotient because the remainder is never 0. So we can continue the process. So it is going on and on. It is not terminating. It is not ending. Never ending process. So we just name it as non-terminating. Okay, yeah, just forget about recurring, non-terminating. Why? Here it is terminating, it is ending at a point, and here it is non-terminating but it is recurring or it is repeating. See, here 3 is repeating, here 142857 is repeating, here 28 is repeating. So we just name it as non-terminating. It is not ending but it is at least recurring or it is at least repeating. Okay, it is non-terminating but it is repeating. Okay, yeah, these are the two cases. Any doubts about this? Are they rational or irrational? Yeah, we are coming to that point. Are they rational or irrational? See, they are always rational numbers. The decimal expansion of a rational number is either terminating or non-terminating recurring. Okay, we first learned about this rational numbers, so that's why we are learning this decimal expansion of rational numbers first. So it is either terminating or non-terminating recurring. Okay, we have a hope. It is non-terminating but at least it is repeating. We know. Can you go back to the previous slide? Yes. Before this? Yeah.
Ma'am, we have hand raised.
Yes, who is that?
Midesh.
Midesh. Yes, Midesh. Do we have any doubt?
Ma'am, in some of the questions in my textbook, they will be given like 0.375 and they'll put bar on only 75.
75, yeah. 0.375. It means it is 0.3757575. It is
Okay.
like that. Okay, only 75 is repeating. 3 is not repeating. After that 7575 it is repeating. Okay. Yeah. See, okay, so here we have seen this. The decimal expansion of a rational number is either terminating or non-terminating recurring. So either it is terminating, yeah, it is ending at a point, or we have a hop. Even though it is non-terminating, it is at least recurring. So we know something about the next digit. We know what is gonna happen next. Okay, it is 3.3333. Yeah, we know that the next will be 3, next will be 3, next will be 3. We know that. Okay, but what about non-terminating, non-recurring? We have some numbers like root 2 is equal to, actually the decimal expansion of root 2 is 1.41421356. See, it is non-terminating and non-recurring. It is not repeating and it is not ending. Similarly, pi. Okay, 3.14 is an approximate value of pi. That is not the exact value of pi. It is an approximate value. So it is 3.1415926. It is going on and on. It is non-terminating and non-recurring. And we know something about this root 2 and pi. Are they rational? Root 2 and pi? No, right? No, right? Yeah, they are not rational. They are irrational numbers. And see, their decimal expansion is non-terminating and non-recurring. Here we have a hop. Even though it is not terminating, it is at least repeating or recurring. So we know what is the next digit. But here we can't even predict which is the next number. It is non-terminating and non-recurring. Therefore, we can say that the decimal expansion of an irrational number is non-terminating and non-recurring. Both negatives, non-terminating and non-recurring. It is not terminating and it is also not recurring. So moreover, a number whose decimal expansion is non-terminating, non-recurring is irrational. So if we have a rational number in our hand, like if it is 3/2, we can say that its decimal expansion may terminate at a point, or it is not terminating but recurring. Okay, but if we have a if we have this 0.525252 like that, okay, so if we have a non-terminating recurring number in here, and we can see that it is a rational number. Okay, so if we have a rational number, we can see that its decimal expansion may terminate or it is not terminating recurring. And if we have a number whose decimal expansion is terminating or non-terminating, we can always non-terminating recurring, we can always say that it is rational. Just understand this: if it is rational, it is either terminating or non-terminating recurring. And for these irrational numbers, we have only one case: non-terminating and non-recurring. Okay, should we write this? Yes. You can just simply write it as rational numbers. Okay, for rational numbers, it may terminate. Okay, terminating. And for, yeah, terminate and non-terminating, recurring. Okay, and for irrational numbers, it is non-terminating and non-recurring. Okay, this is terminating. Okay, non-terminating and non-recurring. Yes. For rational numbers, we have two conditions or two cases. It may terminate at some point, or it is like non-terminating recurring. But for irrational numbers, it is non-terminating and non-recurring. Okay. Is it clear? Is it clear? Any doubts about the decimal expansion? No. Any hand raises? Sir, if you have any doubts, you can raise your hand. Okay, fine. Already asked, right? Okay, everybody, please take your notebook and note down this in your notebook. Yeah. Could you show the previous slide? This one. Okay, yeah, so this is all about this decimal expansion of real numbers. Now we have a question here. Show that this is a rational number. So what is the definition of a rational number? Any number which can be written in the form of p by q, where p and q are integers, to be precise co-prime integers, and q not equal to 0, right? So here we have a number 3.142678. Okay, a terminating decimal, and we have to show that it is a rational number, which means we have to show that we can write it in the form of p by q. Any idea? I didn't finish the previous slide. Oh, okay, wait. Okay. You can also take a screenshot, and after this you can just write. Can you go to the slide with 2 points? This one, right? 22 by 7 is also an approximate value of pi. It is not accurate value. For our convenience, we are taking it as 3.14 or 22 by 7. That is not the correct value. It is just an approximate value. Okay. Yeah, 22 by 7 is not the correct value of pi. It is an approximate value. Okay. Yeah, and what about this question? How can we represent this in the form? Yeah, we have so many hand raises. I have a doubt. Who is that?
Niranjan.
Yes, Niranjan? Where is Niranjan? Can you please raise your hand? Yes. What is your doubt?
Ma'am,
Ah.
I think in the last class in math, there was a test, and in that, and then there was like the third and the fifth question. I remember the number, but I forgot how to do the question. It was like, what is an irrational number? And then they gave like root 2, root 4, and I gave the answer for it, but I forgot how it was.
Okay. So, which of the following? This one?
Yes, ma'am.
Yeah.
So, like, can you know how this works?
Yes. Okay. See, what is root 16? Root 16. 4 square. What is 4 square? 16, right? Yeah. Yeah. So it can be plus or minus 4. Root 16. Just take 4. Okay, don't get confused. Just take 4. Root 16 is equal to 4. Yeah. What is 12 by 3? 4. So this is root 12 by 3 is same as root 4. And what is root of 4?
2 square.
Yeah, 2. 2 square is 4. So root of 4 is 2.
Yes, ma'am.
Yes. Okay. And what is root of 100?
Ma'am, I think it comes like a decimal. No, like something
What is
like that.
10 square?
100.
100. So what is square root of 100?
10 square, which is 10.
10. Yes. So root 100 is 10. All these are rational numbers. 4 is a rational number. 2 is a rational number. 10 is a rational number. So the only rational number is root 12.
Okay.
Okay. And one more question, miss.
The fifth one.
Yes. Which of the following is a rational number?
Also, like we have to find if it has a square or if it can be divided to its smallest, like.
Yeah, if
then
it is inside the square root, we have a perfect square. That is always a rational number. Root of 25 is a rational number. Root 9 is a rational number. Root of any perfect square is a rational number. Okay?
Okay.
Yes, that's it. So here the answer is root
25.
Yes, that's it. Okay.
Thank you, ma'am.
Yeah. Okay, so the question. Yeah, coming back to the question, we have so many hand raises. Unmute. Yeah, I can see the correct answers in the chat box. So we can unmute any one of them.
Ashley.
Okay.
I think like 3.142678. We have to like write it in the fraction from like try 3142678. Like 1 0 0 0 0.
How many zeros?
6 zeros.
6 zeros. 1, 2, 3, 4, 5, 6. So why 6 zeros?
Because the decimal point after decimal point there are 6 digits.
Yes, very good. After decimal point we have 6 digits. Like see 1, 2, 3, 4, 5, 6. So just remove the decimal point and just write the number and put that much zeros, 1 and that much zeros in the denominator. If it is 3.142, okay, what you have to do is just write 3142 and put 1, 2, 3 zeros. Okay, that will be the P by Q form, or that is how we can represent the given number in the form of a rational number or P by Q form. Okay, I can see so many correct answers in the chat box and many of you have raised your hands to answer the question. Yeah, very good. This is the correct answer.
Should we just simplify it?
If you want, you can simplify, but it is not necessary. You can just write it like this, or you can just simplify it and write it. Okay? Yeah. Okay, so, okay, all the hand raises were to answer the question, right? Any doubts, anybody? Yeah, about this. Okay.
Abid.
Yes, Abid? No, okay. So, anybody, any doubts? No, they all raised their hands to answer the question. Okay, guys. Now let's see the next question. Show that 0.333 etc. or it is equal to 0.3. About that we can just put a line which means 0.333 can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. So here it was terminating, right? So we know how after the decimal points how many digits were there. Yeah, 6 digits, and here after the decimal point 3 digits. We know that because it was terminating. But what happens here? Here we don't know after decimal points how many digits are there. It is 0.333. It is going on and on. So what about this one? How do we represent this in P by Q form? Any idea? Yes, John. Okay, we have so many hands, so you can unmute any one of them.
John Patrick.
Yeah.
Yes, ma'am. So we can consider 0.3 bar as x, and we can take 10x as we can add an extra. We can change decimal place.
Okay, 10 into 0.3. So it will be.
Yes. 3.333 because it's a bar.
Okay, so this is okay.
That also includes.
Yes.
Then we have to minus 10x with x, which also includes the 0.3 bar and 3.3 bar.
Okay, so 3.3333 minus or 3.3 bar. Okay, whatever. Etc.
Yes, which eliminates the decimal point, which leaves us with 3.
Okay.
And we know that
10x minus x is?
then that should be 9x.
Yes. Okay.
And then we can evaluate it by putting 9 on the opposite side and leaving x there.
Okay.
Which should be 1 by 3.
Yeah, very good. So x is equal to 1 by 3 is the correct answer. Very good. Very well explained. So x is equal to 1 by 3. Yeah. So the decimal expansion, you can watch the video. Okay. Yeah. So x is equal to 1 by 3. That is, yeah, we have seen this. 1 by 3 when we divided 1 by 3. See, when we divided 1 by 3, we got it as 3.3333. Okay, but here only 3.33 was given, right? And we need to express it in the form of P by Q. So what we do is, we always take the given number 0.3 bar or 0.33 etc. as x. Okay, whatever is the number, if it is 0.9 bar, just take that number as x. Whatever is the given number, just take that number as x. Okay, now here, see, only one digit is repeating. Okay, only one digit is repeating. So take 10x. Okay, only one digit is repeating. So take 10x. And 10x, what is 10x? 10 into x. And we choose, okay, see, let me write it again. So first of all, take the given number as x. Okay, take the given number as x. Now only one digit is repeating, only one digit. So after 1, put 1 0. Only one digit is repeating, so 10. So take it as 10x is equal to, what is 10 into x? 10 into 0.3 bar or 0.33. So it will be 3.3 bar, right? So instead of multiplying a number with 10, if it is 3.1 into 10, what we do is we just take one decimal point to the other side, right? Or if it is 3 into 10, what we do is it is 30. If it is 3.1 into 10, we will just write the take one decimal point towards the other side. Yeah, so just like that, we have 10 into 0.3 and that is 3.3, right? Okay, now what we have to do is just subtract. Okay, 10x minus x. What we have to do is we just want to remove this 3 bar. Okay, that is why we are doing 10x minus x. What is 10x? 3.3 bar minus 0.3 bar. What is remaining? We have a 3 there. 3.3 bar minus 0.3 bar is 3 and 10x minus x is 9x. So x will be equal to 3 by 9. When we write it in the simplest form, we will get x is equal to 1 divided by 3. That is the required okay. Yes, we can solve more questions. See, here we have 1.27 bar. Okay, before that, any doubts about this question? Yes, Rishikesh, what is your doubt?
Ma'am, it will be 1 by 3.
1 by 3, yes. Okay, next.
Ma'am,
Next. Yes. Okay. Next. Any doubts? Anybody? He may raise his hand to answer. If you have raised your hand to answer the question, please lower your hands. If you still have any doubts, yeah. No. Okay. Yes. Said. Yes, Said. Rihab. Okay, Rihab. Yes, Rihab. Said Rihab, right? Yeah. Okay, Said. No? You are not audible, Said. How did 3.3 bar come in the first step while multiplying? See, what is 10x? Okay, we are taking 10x, which is 10 into 0.3. So instead of multiplying with a number with 10, what we do is, if it is 0.3 into 10. Okay, what we do is, we just take one decimal point towards the right side. So it will be 3, right? Okay, so if it is 0.2 into 10, we just take one decimal to the other side. So just like that, 0.33 into 10. Okay, 0.33 into 10. Take one decimal point towards the right side. So it will be 3.3. Okay, yeah. So here, okay, so here x is equal to 1 by 3. We have already answered that question, right? Who is that, sir? Yeah, name.
Sharia.
Eh?
Sharia.
Sharia. Okay, so q must be a multiple of 2 raised to m into 3 raised to n. Okay, Sharia, only to you. Okay, q must be a multiple of 2 raised to m into not 3, 5 raised to n. 2 raised to m into 5 raised to n. Yeah, that's it. Okay, now the next question is, show that 1.2727 etc. that is 1.27 bar can be expressed in the form of p by q, where p and q are integers and q not equal to 0. So here 2 digits are repeating, right? Here only 1 digit was repeating, only 3 was repeating, and here 2 digits are repeating, 2, 7. 2 digits are repeating. So what we do? Yeah, we can unmute someone.
Ramzi.
Okay.
Ramzi.
can I answer?
Yes.
X is equal, so we will take 1.27 bar x.
Yes, 1.27 bar, the given number as x. Okay, now we have to take 10x.
100x equal
Yeah,
to,
very good. 100x. Why 100x?
because 2 digits are repeating after.
Yes, 2 digits are repeating, so we have to take 100x. Here only 1 digit was repeating. Okay, so we took 10x, and here 2 digits are repeating, so we take 100x. Yes.
Equal to 1.27 into 100.
1.27 bar into 100. That is
Equal to 127.2727.
okay. Now,
So we subtract 100x by x.
okay.
It is 126.
Oh.
99x equal to 126.
99x equal to 126. Okay, so it is
X equal to
127.27 minus 1.27 bar. Yeah, okay, 126. Okay, x is equal to
126 by 99.
okay. Yeah, 126 divided by 99. Yes, if you want, you can also simplify this. When we simplify this, we will get the answer as 14 divided by 11. Okay, yeah. So 126 by 99, I got the answer as 127 divided by 100. That is wrong. See, if it is 127 divided by 100, it is 1.27. Okay, but this is not 1.27. Here our number is 1.27272727. It goes on and on. Okay, it is 1.27 bar. Above this 27 we have a bar, which means it is 1.272727. So if it was 1.27, yes, 127 by 100. Okay, fine. But since it is repeating, it is recurring, we can't do that. Okay, we have to follow this step. If it was 1.273 bar, you can take 1000x and do the same steps. Okay? Yeah, and the only thing is, here it was 3.3 minus 0.3. Okay, if it was 3.333 is there and 0.333 is there. Okay, here both are same, so it will get, we will get 3.00 or just 3. Okay, just 3 we will get. And here, since this is okay, the first one is 127.2727 like that, and the other one is 1.2727. Okay, you must be careful. Here it was 3.333 minus 0.333. So here 3 minus 0 was 3. Yeah, 3 minus 0 was 3. But here we have 127 minus 1 is there. So it must be 126. Please don't write it as 127. It is 126. 127 minus 1 is there. Okay, and this is, yeah, 0, 0. So you just take 126. We know how to subtract decimal numbers, right? Yeah. So any doubts here? If you don't have any doubts, you can just lower your hand. Anybody, any doubts? Yes, Abid, any doubts? Okay.
What is the pi value?
Pi value is this. It goes on and on. Okay, it is not ending, it is not terminating, non-recurring.
Okay.
Yeah. And next one, Ruben. Do you have any doubt, Ruben?
Yes, ma'am. Can you go to the previous slide?
Yes, okay.
Ma'am, I didn't understand this one. This one. 126 divided by 99. No, I didn't understand how we got 40.
Okay, 126 by 99. Wait. 126 divided by 99. So, can we divide this 99 by 2? Is 99 a multiple of 2?
No, ma'am.
No. Okay, what about 3?
3, no.
Yeah, okay. 3 into like 33. See, 99
Oh,
by...
33, yes.
Yeah, okay. And what about 126? 126 by 3.
4
2s are...
4 twos.
Okay, then?
3 twos are 6.
Yes, so it is 42 by 33.
Oh, yes. 42.
Yeah, then again can we divide it by 3?
Yes, ma'am.
Let's see. So what is 33 divided by 3?
Ma'am, 3 ones are 3.
Okay.
Then 3 ones are 3 again.
So it is 11.
Yes.
Yeah, and what about 42 by 3?
42, I think so, we can't. No, for...
Let's see. 1 3s are 3.
Yes, ma'am.
And 12. We have 12.
Oh. Then 3 4s are 12.
Yeah, so it is 14.
14.
So we got 14 by 11.
Okay.
Yeah, and let me tell you something. We have an easy method to check whether a given number is a multiple of 3 or not. Okay, here we have 126. Just add the digits. 1 plus 2 plus 6. The number is 126. Just add the digits. 1 plus 2 plus 6. We will get 6 plus 2, 8, 8 plus 1, 9. So 9 is a multiple of 3. So definitely this number will be divisible by 3. Okay, so again you have 42. To check whether this number is completely divisible by 3, you can always add the digits. 4 plus 2, 6. 6 is divisible by 3. So this 42 is also divisible by 3.
Yes.
Okay, yeah, divisibility rule, yeah.
Yeah.
Okay.
Like, so ma'am, if you wanted to check, like, for example, we did the answer and what, for example, like, for example, 126 by 99, and when we do this, 99 was not a divisible number, so 126 by 99 will be the answer, right?
Yes.
Okay.
Okay.
Thank you.
Any other doubts? Ashlyn, do you have any doubts? Yeah.
Ma'am, can you go to the 0.3 slide, madam?
Yes. Yes.
What 2 m into 5, what was 1
Okay, some question was there in the chat box. Okay, I just answered that question. Like, what is the property that Q must satisfy? Yeah, that's it. Okay, it is nothing related to this one. Okay. Yeah. Okay, exam time. Yeah, exam.
Can you explain that?
That question. Okay.
Yeah.
Next class we can discuss because it's time for exam. That question I will discuss next class. Okay. Yeah. Okay, now it's time for exam. Everybody be ready for the exam. And yes, sir, please inform. Okay, to the new students, you can just minimize your Zoom and then there will be something exam schedule. Just click on it. Can you show the previous slide? This one. Okay. Okay, just minimize your Zoom and there you can see exam schedule will be there. And just click on it and you can attend the exam. Just enter your full name and your roll number. If it is not there, just refresh your page. There you can see that. Still it is not coming means you can log into the website. You will always log into a website for attending the class, right? So just log into the same website and just below this link for class, you can see another link for exam. Yeah. The number of entries in the repeating string of reminders is less than divisor, 5, remainder, none of this. If the decimal expansion of a number terminates or ends after a finite number of steps, we call the decimal expansion of such numbers non-terminating. So the number is terminating or ending after a finite number of steps. We call it as non-terminating, terminating, recurring, none of this. 3.62 is dash decimal, terminating, non-terminating, non-terminating, recurring, none of this. Then we have 3.333 etc. is terminating, non-terminating, non-terminating, recurring, none of this. Last question, a number whose decimal expansion is terminating or non-terminating recurring is irrational, rational, natural, okay, irrational, natural, rational, integer. Okay, very good, 10 out of 10, 8, yeah, very good. 10, okay. Is there anyone who is still struggling for the link for exam? Anybody? Everybody got the link, right? Okay, 10, very good. Yeah, very good. 10, 8, yeah, very good. Yes, Niranjan sir.
Ma'am, in the third question, ma'am, like 3.62, ma'am, is it
Yeah,
like,
please don't tell. Please don't tell me the answer. Okay, some people are.
like,
Okay.
no, like, is it like the number ends there?
Yeah, it is just 3.62.
It ends there.
Yeah. So if everybody completes the test, please let me know. I got said. What is the green? Yeah. Okay. Very good. Actually, you don't have to turn off your camera to attend the test, right? So your camera must be on. What? Sir, could you please check it? What? First one. No, before that, answer. Yeah, we can discuss the answers. Before that, anybody still attending the exam? Please raise your hand. Yeah, okay. We have some hand raises, okay. Yeah. Sir, hand raise. Chris, yes, Chris? You are still right. You want to answer this question. Okay, shall we discuss the answers, guys? Yeah, okay. The number of entries in the repeating string of reminders is less than the divisor. Yes, very good. We have just discussed this thing, right? That was, yeah. Yes, Chris, very good. See, the number of entries in the repeating string of reminders is less than the divisor. And we have some examples here. Here the divisor is 3 and only one digit is repeating. Okay, one digit repeating and the divisor is 3. Right? Yeah, and here we have 7 by 8 and here the divisor is 8 and only the repeating, no, nothing is repeating here, and here the divisor is 7. Okay, divisor is 7 and it is repeating, 6 digits are repeating, 6 is less than 7. Okay, so it is always less than the divisor. Then the second question, if the decimal expansion of a number terminates or ends after a finite number of steps, what is that, chat, sir? Okay. We call the decimal expansion of such numbers terminating. Yeah, okay. Then the third one, 3.62 is it's ending. So it's terminating. Okay, then next question. 3.3333, etc., etc. It goes on and on. So it is 3. Not terminating but recurring. Okay. Yeah, the last one. Number whose decimal expansion is terminating or not terminating, recurring. Rational. Okay, a number whose decimal expansion is terminating or not terminating but recurring is rational. That's it. Any doubts? No. Very good. So if it was non-terminating, non-recurring, then that is an or a or an. Okay, can you show the first? Yes, it is an irrational number. If it is non-terminating, non-recurring, it is irrational. First question, yeah, the number of entries in the repeating string of reminders is less than the divisor, which means if the divisor is 7, you have to check up to 6 decimal points. Okay, after the 6 decimal points, it may repeat. If it is, say, some 6, you have to check up to 5 decimal points. It may repeat after this 5 decimal points. Okay, yeah, that's it. Show answers. First question, it is divisor. Then for the second one, it is terminating. It is ending or terminating. Then it is 3.62 is terminating. Then 3.33 etc. is non-terminating, recurring. And a number whose decimal expansion is terminating or non-terminating, recurring is rational. Yeah, that's it. Okay, so see you all in the next class. Until then, stay safe, take care, good night, bye-bye.